Hello and welcome to Subpart 5.5 of the BMS modding tutorial series. In this video I will show you how you can potentially implement a workable solution for an internal forward-looking infrared sensor and/or electro-optical targeting system. I say potentially as the workaround solution requires a minor update to be performed on the aircraft's external 3D model. Unfortunately, this update cannot be performed on a BML model using the model viewer, as its limited editing capabilities are insufficient for this purpose. The only two solutions that remain are to either update the source model in 3ds Max or Blender, or to update a LOD version of the model using LOD Editor. The LOD format has been superseded by the BML format since BMS 4.37 Update 3, which was released in October 2023. I do not recommend to reintroduce an old model, if the subject aircraft's model has been updated or even replaced with a new model since then, as it has a couple of side effects or knock-on effects. If a model has not been updated however it has no negative effects. What is this workaround all about? The answer to that question is, that if you are also flying other aircraft in BMS, that incorporate a FLIR and/or EO targeting system into their airframe, it is of course desirable to get that capability implemented in SIM as well. BMS 4.33 has introduced the option to select between internal or external sensors. The problem with internal FLIR and TGP sensors is, that their position is hard-coded into the executable. It defines a fixed offset position relative to the aircraft model center. These fixed position data are probably tailored to the F-16. For aircraft that are larger, or have a different geometry it may translate to the sensor sitting inside the airframe. The video imagery these sensors deliver can therefore be masked by the airframe, rendering them useless. At the other fighters Mafia a workaround solution has been developed to provide an operationally usable capability, without compromising the payload capability, aerodynamics, or visual properties of an aircraft, as is to be expected for an aircraft with internal systems. It is still a workaround solution though, and you will need to load those sensors like external stores, but they don't have the above-mentioned limitations of an external pod. In a nutshell, the workaround solution is centered around creating additional, invincible store stations and define them as pod stations. Creating corresponding, internal, sensor stores and load them to these stations. So let's dive into the details.
For this lesson I will use the F-35B Lightning II aircraft as a case example. This variant of the F-35 has just recently been added to the database of the OFM KTO add-on theater that's currently in works for the BMS version 4.38, and the objective will be to add the internal targeting pod workaround solution as a substitute for the real aircraft's electro-optical targeting system, or EOTS. So the workflow process starts with the creation of the EOTS dummy store. To do this I'm using the editor. We are in the weapons primary, weapons secondary tabs, and I'm simply using an existing targeting pod as a template. Using the sniper targeting pod, simply right click, select add weapon copy, and the pop-up window you are asked whether you also want to duplicate the associated class table record entry. We confirm this, and so we have already two of the three database record entries required. It's being added to the end of the index list for the weapons control data, in this case 1112. I will later on reposition it to a lower number because it's important to take into account that if you have weapons or stores that are loadable to an aircraft and you want to have a defined quantity in the squadron stores data, the weapon control data index number must be not higher than 999. So the policy that I have in this case adopted is to only use the higher numbers above 1000 for racks and other stuff that's not directly loadable to the aircraft, but just as a side note. So we are now opening with a double click, rename the sensor to EOTS, as it's supposed to be an internal dummy store. It should neither add weight nor drag if loaded. So we change both values to 0. What we are also doing is to open the corresponding CT record number and check out the SIM weapon data index number for the pod. It's 160. So we temporarily save, go to the SIM weapon data subtab, sort by index number, searching for 160. That's that one. Now right click at SIM weapon copy. So we have created the third and final database record entry on the pods that we need here. I will simply rename it to EOTS. Other updates are in this case not required. So it's a new index number 604, and what we are now doing is going back to the EOTS, open its CT record entry and change the SIM weapon data index number assignment, going to 604 in this case. Final thing to do is the graphics. At the moment it's linking to the sniper targeting pod. We change it to 11,040. That's actually the model that I've already created for the FLIR. I'm using the same model. It's just an empty model file, so to speak, so there's no model as such behind it, but we need to link the pod to something, and so it's an empty model file that we can use for all kinds of purposes where an empty model is required. 0 may work in some conditions, but not always. Okay, so we have created the sensor. I can briefly show you how you can use a lot editor to create such an empty dummy file. You go to File, a new model. We can keep those data, no textures, and then we would call it EOTS, for example. Press save, and when you want to open it, you can open it. There's nothing in there, so there's nothing to be done. Same as for the FLIR that I've already created. It's called Pirate because it was originally created for the EF2000. So same empty model file. I will therefore not repeat the complete process. What you would have to do now in theory would be to go to the Models tab, browse, and then you have the EOTS slot here. You can now click OK, conversion finished, and in the corresponding directory you will appropriately have a new BML file. What you would also need to do is to create a parent file, so you can adopt this data, limited data. It's very important that the model 0 BML entry matches the name of the model file itself. So it should be EOTS .bml, for example, and then all you would have to do is to create a new folder, number it accordingly. For example, the last one here is 11,119, so I would create an 11,120 folder, move the EOTS BML and parent file in there, and that's it already. And then you have to link to the specific model from the CT record of the object. As said, we won't do this now because we already have a model, such an empty dummy model. That's aforementioned number 11040, so I will not create a second one because this one can be reused and pointed to from as many other database record entries as required. Okay, so this already concludes the EOTS. Second thing would be to also create a rec file or rec database record entry. We won't repeat this process. It's the same as shown before. You just use rec as an example and do the same things. I have already the rec Eurofighter FLIR. That one will be reused for the F-35B as well. So you don't need to create a separate rec entry each time, just once, and that could be used for FLIR or the EOTS as you like. So if you then add internal FLIR or targeting pod sensors to other aircraft, you can simply reuse these and don't need to create them over and over again for each and every aircraft. You just do it once and reuse it on multiple aircraft. So let's move on to the aircraft part. I have opened the F-35B models lot file. Here you can press isolate, so everything that's not being directly selected is not being displayed. And if you click on slot, you get the slot positions displayed. So as you can see, we have a total of 11 stations already defined, and we now need to create a 12th station that serves as our dummy pod. So to do so, you can with Control and left click simply select slot, and in the tree the corresponding record entry is being shown and highlighted accordingly. We now want to create a new slot for the model. So what we do is pressing here channel pointer, selecting that we are creating a new slot up here, and here we can already define the slot sequence number. That one is important. We have already 11 stations. In lot editor, the station slot 1 starts actually with 0, so these 11 stations already occupy the station slot numbers 0 to 10. It's very important that you add this slot sequentially to the end of the existing hard points that you want to use. So 0 to 10 are already in use, so we name it 11. So it's now created exactly at the center position because we have no coordinates defined yet. What we now do is to deselect, isolate to get the model displayed again. I am right clicking and now determining the coordinates or positions, offset positions from the center. That's 1, the 0 point, so to speak, and distances to the front are measured in feet plus, in this case, that's displayed here at the top, X, Y, Z coordinates. The EOTS sensor of the model is located here. You can zoom in a little bit for greater precision. So we select this position, that's X23 400 and Z 20.70. So I'm opening this final slot, enter these coordinates, Z position to 7, and the other one was 23.4 if I'm not mistaken. Accept. Yeah. So that's it already, because the sensor is centered. We don't need to create a Y position. We may move it a little bit forward just to be on the safe side. And as you can see, the sensor is now mounted here. If we select isolate, you see the small blue X. If it is visible, that's the defined position of the station slot. So all we do now is to save. You can close that one. The next thing that we do is to browse to the appropriate folder where the model is located in. It's in this case 11,112. You can see that's a log file. You can also verify through date and time. Okay, that's the one that I've just edited, so convert it, and now we have the model updated. What we have to do now in the editor, let's first create a new weapon load data record entry. So under weapons primary tab, hardpoints subtab, let's simply create a copy. This station has no particular stores at the moment. We call it simply EOTS. And now we select the EOTS. Index number is probably the easiest way. Increase quantity by 1. That simply means that one EOTS spot can be loaded to the station. We press save. The next step that we need to do is to go to vehicles aircraft. Select the F-35B. Go to the weapons tab here at the bottom. We currently have 11 stations, so we want to create a 12th station. So we create hardpoint or add hardpoint. So that's the one created. What we don't need to tick in this case is visible or rec. Can do this, but makes little sense. And now we are searching for the EOTS. That's this one. So we have the store assigned to the aircraft here. The weapons control data record entry is in this case 1112. We can keep it open in the background. We need that one later on. What we do now is we go to the BMS rec dat. So if there would be no rec defined, I had to create a new one. I will now simply go to the one that I have already created. So you have to create the rec itself define rec, you can name it as you want. In this case, it's EF 2000 FLIR. It links to the CT record for the rec. Yes, in this case, we have everything to none. We don't want to get it displayed on the SMS page. We have one rec station, so only one store can be loaded. There's no jettison included, and we also add the weapon ID. And that's exactly the store that we want to load, so the 1112. The other one is the FLIR, but I have moved it, so it's already a small bug identified. I sort by name. The FLIR that we have added is located here. It has a 900, so we have to update this as well. So it essentially links to the specific weapon control data index number, that one for the FLIR and that one for the EOTS. It simply states if you load this weapon or store, then this rec would be used. So the second thing that we have to do, we move down to define group. In this case, you can also enter the name that you want. It's the same as the rec name. So you add pylon, you can define a pylon's name. It's in this case not really that important because it doesn't show up on the SMS page anyway. And then you need to add the rec that we have defined above. So, and now what we have to do is to keep that open or in mind, I will copy it. Then we are opening the aircraft data file that's located under sim AC data, and then you have to find the corresponding txt pb file for the correct aircraft, in this case F-35B. We are using the search function and the hardpoint. Now you have the hardpoints. Important is the first, and there are 16 entries in total. The first one is always 0, and then you have to define the names. In this case, it's the rec group names from the BMS recdat, and we want to add another station, the 12th one, and that's the EF2K FLIR, so it links to this rec group entry, which in turn links to the particular rec in this case. Okay. So what we also have to do is we define number of put stations as 1, and the code will always process the last station as the first put station. That's the reason why this station is station 12, so it doesn't interfere with the existing external, and in the case of F-35 also internal stations. And we can now briefly take a look at the TGP. So the TGP is in this case defined as internal. We now have to turn it into external. If it would be at internal, we would have the usual problem of the camera sitting somewhere within the airframe. I won't specifically show it to you now. It's just important that you can define the TGP type, so replace after the pod underscore external with internal, or none. None means even if you have an external pod loaded, the functionality is not available. You have, by the way, also a couple of other additional data herein. But that's something for another video. We have now defined it. What you can see here are the offset positions that you could in theory populate. So if I would enter these numbers that I have already entered to the station, it should ideally work. In practice it doesn't work. That's the problem. You can define an offset position, but it's not being processed by the code, and that's the problem that we have. So I save the change. If at some point the current limitation is being addressed, then we could simply switch to internal here and revert all other changes, or simply take them out. It's not a problem that the 12th station is inside. If inside the model itself, the external aircraft model, you just need to remove them from here and from the database, and then it simply disappears altogether. So that's this step. Another thing that I need to update where we were at it. You of course have to add the new 12th station here also at the end. So I simply create add slot, define the coordinates we had, 23, 5. Y position is in this case 0, and then Z position 2.7, and that's it already. And so we have added the EOTS to the aircraft. We can make a brief launch test. So we are quickly creating a TE mission with the F-35B. So we can check the weapon loadout, go to all or other, it's easier, and now we have the EOTS here. So if you load it, there's no visual impact. So we can briefly conduct a test. So we are now in the cockpit. Activating the TGP. And there it is. So it works as it should. It's not visible, it does not compromise your weapon loadout, it does not add any weight or drag, so exactly what we expect from the internal system. That concludes this lesson. The process for the FLIR is the same. It's called a lantern in the aircraft data file, but the process is otherwise exactly the same. In this case, it's of course wise to choose a FLIR navigation pod like the ANAQ13, as I have done for the existing FLIR already. You can, of course, if you want, also add 2 stations to an aircraft and then define 2 pod stations in the aircraft data file, so you can simultaneously load a FLIR and an EOTS, so to speak, without any other compromises. In this case, it's just important to take into account that you will then need a left and right hardpoint power switches to be appropriately assigned in the cockpit so that everything works as expected. So, thank you for watching and see you next time. Bye.